basic concepts, means how to measure similarity between objects. Since clustering is an unsupervised learning process, so we do not have predefined labels to judge whether it's right or wrong. So how can we judge a clustering process is good? That means whether it will produce high-quality clusters. Usually we give two measures, one called high intra-class similarity, the other called low inter-class similarity. What is high intra-class similarity? That means you want to see the objects within the same cluster. They are rather similar, they are cohesive. You also want to see inter-class similarity is low in the sense you want to see the objects in different clusters. They are rather dissimilar or they are distinctive. So to measure this, we need some separate quality function to measure how good a cluster is. However, it is hard to define what is similar enough or good enough. The answer usually could be quite subjective. That's the reason we want to look at different similarity measures or the similarity functions for different applications, but they are critical for cluster analysis. For terminologies, people actually want to distinguish quite interesting similar things called similarity measure, dissimilarity measure, or proximity measure. What is similarity measure or similarity function? Usually, similarity function is a real value function to quantify the similarity between two objects. Usually, the higher value, it means more similar. So the value range is 0 to 1. 0 means there's no similarity. 1 means they are completely similar or they are identical. Then, similar to similarity, many people want to use dissimilarity or distance measure. Distance measure or distance function is a numerical measure to measure how different these two objects are. To some extent, the dissimilarity is inverse of similarity. That means the lower or the shorter the distance, the more alike. The minimum dissimilarity is 0, means they are completely similar or identical. The value range could be either 0 to 1 or 0 to infinity based on the definition. Another term called proximity, this is usually referred to either similarity or dissimilarity. Now we examine section 2, distance on numerical data, Minkowski distance. So we first introduce data matrix and dissimilarity matrix or distance matrix. Data matrix is represented in the typical matrix form is we have n data points, we use n rows. We have L dimensions, we use L columns to represent this data set. The distance matrix or dissimilarity matrix usually is represented in triangular matrix. Because you have n data points, we register only the distance between like objects 1 versus 1 or 2 versus 1 to look at their distance. Okay. But the distance function usually could be quite different for different kinds of variables like a real, Boolean, categorical, ordinal, ratio, and vector variables. Their distance definition could be different. Moreover, sometimes they may have weights associated with those different variables based on the applications and data semantics. We're going to introduce this more later. Then we look at an example. Suppose we have 4 points, 4 objects in 2-dimensional space. Okay. Then the data matrix is represented in this typical form. Okay. Then for dissimilarity matrix or distance matrix, for Euclidean distance, you probably can see the matrix is in this way. Like x1, x1, they are identical, their distance is 0. x2, x1, their computation is based on the distance. This part is 2, this distance is 3, You take sum of the square, you take square root, you get this value. Then in general, we define the Minkowski distance as this formula. That means if we have error dimensions for object I and object j, then their distance is defined by taking every dimension to look at their absolute value of their distance, then to the power of p, then you sum them up, get the root of p. Then we get the Minkowski distance. Such distance, the p is the order. We usually also call this distance as LP norm. The Minkowski distance in general have these properties. The first property is called positivity. It means the distance must be 0 when they are identical, otherwise they are greater than 0. Okay. The second property called symmetry means the distance between I and j, distance between j and I should be identical. Then the third one called triangular inequality means for the distance between I and j, if you go through k, that means you go first to k, then from k to j, that distance should be no less than directly go from I to j. It should be greater than or equal to directly go to I to j. Okay. The distance measure that satisfies these three properties called metric distance. Notice not all the distance are metric. For example, set distance is not metric. Of course, in this lecture, we mainly discuss metric distance. Then we look at some special cases of Minkowski distance. If p equals 1, we call L1 norm. They also call Manhattan or city block distance, defined this formula. In particular, if we are dealing with binary vectors, we call these as a Hamming distance. It's the number of bits, they are different. Then if p equals 2, it's defined, also called L2 norm, is Euclidean distance defined in the typical way like this. This is a very familiar one, I think, for all the people. Okay. Then if p goes to infinity, means we're dealing with L infinity norm or L max norm. This is also called Superman distance. Is defined is a limit for p goes to infinity. In that case, actually the distance is really the maximum difference between any attribute of the vectors. For example, you can see for f from 1 to L, the maximum such absolute value of the distance is the distance of L infinity norm or Superman distance. Let's look at some examples. For the same data sets, like we get 4 points, we get 2 dimensions. Then we look at the Manhattan distance is just based on this is city block distance, for example, from x2 to x1. You will go 3 blocks down, then 2 blocks left. So the Manhattan distance is 3 plus 2, you get 5. Okay. Of course, x1 to x1 itself is 0. And Euclidean distance, as we discussed already, that's the measure. For Superman distance, L infinity norm, you probably can see x2 to x1. So probably you can see the difference is you first go down 3 blocks. For Manhattan distance, you can see you get a 3 plus 2. But for Superman distance, you just see which attribute to get a maximum distance or maximum difference. So you probably can see the maximum one is 3 instead of 2. That's why x2 to x1 is 3. So it's pretty easy to compute. Thank you.